Hi, everybody. Last week we started talking about inheritance and genetic variation, and I'm feeling really sad because this is a lot easier to teach when we're face to face in a classroom. So I'm missing everybody really right now, and I feel like we would get more out of these lessons if we were all together, but it is what it is. Um, Genetics can be confusing. So I'm asking you to watch the video from start to finish today. Try to pay attention. And if you start to get frustrated or feel confused, just pause, take a deep breath, and, don't give up. This takes practice. What we're going to learn about today are Punnett Squares, and it definitely takes practice to understand them. Some kids will get it right away, but most of us have to practice a few times before we're like, oh, okay, I understand how to do this now. Okay, so don't sweat it if after watching this video you're still unsure of what you're supposed to be doing. Okay, we're going to be practicing. There's also a lot of new vocab that's tricky. I'm not going to lie and say that it's easy. A lot of the words sound alike, so take it easy, do your best, and we'll practice vocab this week as well. The first word I want to go over is genotype, and genotype has to do with your alleles that you get from each parent. Alleles, that was a word that was in the assignment from Thursday and Friday. Alleles are represented by letters, okay? And the dominant allele is always a capital letter. This genotype means that the child got a big B allele or dominant allele from each parent. That means that the genotype is big B, all right? The dominant allele is always represented as an uppercase letter. Now, there's also a recessive allele, okay, and that's the hidden trait. We'll go over what that means in a little bit. That's always represented by a lowercase letter, okay? So to simplify, I'm just going to say little b. This genotype is little b, meaning that the child got a recessive trait from each parent. You can also get one dominant allele from a parent and then a recessive allele from a parent. If that was the case, then your genotype would be big B, little b, or whatever letter we use. So whenever we're talking about different traits, they're usually represented as different letters, and the dominant trait, like I said, is always uppercase, and the recessive trait is always lowercase. So every person has a genotype based on what alleles they inherit from each parent. Genotype has to do with the genes that you have in your DNA. The phenotype, on the other hand, is the physical appearance. It's how you end up looking, basically, based on what genotype you have. So the phenotype starts with a PH. Remember physical. Okay, so like physical trait or physical characteristic or what you can see. So we're going to talk about curly hair and straight hair. Okay, so hair type as a trait today. And we'll also look at eye color as a trait. Those are two traits that are easily observed. Okay, so genotype has to do with the genes that you have, and then the phenotype is how those genes are expressed. So if the dominant trait is expressed for eye color, you would have brown eyes, okay? Because the capital letter, if you have a capital letter present in a genotype, that means that the dominant trait is going to be shown or expressed, okay? Even if you have a dominant allele and then one recessive allele, the recessive allele will remain hidden, okay? You'll carry that trait. You could pass it on to your offspring. So your offspring could have blue eyes, but you have brown eyes. Okay, so maybe you have that situation in your family. I know that my mom has brown eyes, my dad has blue eyes. I have blue eyes. My sister has blue eyes. And blue eyes, in this case, is the less common trait in this area, and it's also recessive. Um, so we determine the probability of the different genotypes we might have, or our offspring might have, or other people might have, based on Punnett squares, and that's what I'm going to go over today. Punnett squares begin by labeling this 4-square box with the genotype of one parent up here, and then the genotype of another parent over here. Okay, so both parents here have a genotype of big A, little a. And for all intents and purposes, this is going to be straight hair and curly hair. So parent 1, okay, both alleles are up here, big A, little a, and then parent 2, big A, little a. And then the child can end up with any of these combinations. So all 3 different genotype combinations are represented in this particular Punnett square. So curly hair is dominant. It's represented by the capital A. Straight hair is recessive, represented by the lowercase a. And the 3 different genotype possibilities are big A, big A, big A, little a, or little a, little a. And if you look right here, we fill in these boxes by crossing. So there's a big A here and a big A here. So we're going to write that genotype or allele combination in this box. Okay, then we're going to go over here. There's a big A here and a little a here. That means that the genotype that goes into this box is the allele combination of the big A and little a. So we're going to look here and here for this box, and then here and here for this box. And it's useful to usually go in the same order. I go across here and then across there. So let's do an eye color example. If you look over here, we have the phenotype is blue eyes or brown eyes. So depending on the genotype that the child ends up with, okay, there's a probability that we'll be able to figure out if they'll have brown eyes or blue eyes. So parent 1 is up top, and so I labeled that genotype from parent 1 here, big B, little b. And then parent number 2 has a genotype that's big B, little b as well. So both parents have the same genotype. And then we're going to practice filling in each box of the Punnett square. So think for a second and see if you can remember what I did in the last slide to complete the Punnett square. And then we'll check it. All right, so let's see. The first step is to fill in this top box. You're crossing, you're looking here, and there's 2 capital letter B's. So we're going to put both of those in this box, okay? We're going to fill in this box next, so see if you can get that combination correct. Okay, hopefully you were thinking big B and little b, all right, because that is what goes in that box. And then we're going to do this box next, which would be big B and little b. Notice that if there's a capital letter, the capital letter always goes first, okay? Like in here and here. We have 1 empty box left, which will be little b, because there's a little b here and a little b here, okay? So there are 3 possible genotypes represented in these 4 boxes, and we're going to think about that to get our probabilities. So for big B, okay, there's only one box or one square that has that genotype. That means that it's 1 out of 4. Okay, so 1 out of 4 boxes has big B. That would be 25%. Okay, big B, there are 2 boxes out of the 4 that have that genotype. So that would be 50%. And then the last box is little b. That's only 1 out of 4. That's 25%. So when we're doing probabilities, that means that there is a 25% chance that the offspring of parent 1 and parent 2 will have a big B genotype. There's a 50% chance that the genotype will be big B, little b. And then there's a 25% chance that it will be little b. If there is a dominant allele in a genotype, that will be expressed. That means that if there's a capital B, okay, the eye color is going to be brown. If there's going to be blue eyes, it has to be lowercase b. Does that make sense? It might not yet. That's okay. I feel like if we were in the class, I would have to explain it several times. I am going to go over one quick example before I end this lesson. But just to go over this one more time, because 3 out of 4 boxes have an uppercase B, there is a 75% chance that the child is going to have brown eyes. Okay? There's only a 25% chance that the child will end up with blue eyes. That's because I have the capital B present in both of those genotypes. Okay, that's 50 plus 25, that's 75%. And then only 25% is left. That's for this one box. So most likely the child will end up with brown eyes here, but it is possible that the child could also have blue eyes. Here is another example. I'm not going to go square for square, but you'll see that parent 1's genotype is different. It's big B. All right. Parent 2's genotype is big B, little b. So we have 2 big B's here, 2 big B's there. And then down here we have a big B and a little b, and then a big B and a little b again. So 2 out of 4 boxes have big B's, and 2 out of 4 boxes have big B, little b. So that's a 50% chance that the child's genotype will be big B, and a 50% chance that the child's genotype could be big B, little b. Regardless, this is actually wrong. There's a 100% overall chance that the child's going to have brown eyes. There's a 0 chance that the child will have blue eyes. Okay, so no matter what, if the parents have these genotypes, the child's eyes are going to be brown, no matter what. Make sense? I don't know. All right, this is the end of my lesson. Like I said, if you don't understand it yet, bear with me. It was not easy recording this lesson. I'm going to be truthful. This is the 5th attempt. It's late. I'm tired. And we're going to stick with this. We're going to practice one Punnett square independently after watching this video. And then we'll practice a little bit more tomorrow with Punnett squares. Wednesday, I think we'll probably play a vocab game. And Miss Collins and I are here if you're confused or if you need help. The best way to understand this is to practice. I usually say you'll eventually have an aha moment. I know you will. Just stay calm. Don't give up. Stick with it.